Staying alive, staying alive. So, you are way too young to know that this is John Travolta, and probably your parents are probably too young, but someone my age, if they hear this song on the radio, this is what they're going to be doing. It's a classic get up and boogie kind of song. And so, John Travolta, I'm sure you've seen him in movies. I hope. I hope he's not, too old for you guys. Um, this idea of what does it mean to be alive and stay alive, those concepts are going to follow you all the way through high school. And so you have to have a good conceptual understanding of what it means to be alive. You are going to be asked several times through your academic career on whether or not viruses are alive. And you should be able to conceptually defend your stance or ideas on that subject. And so this part asks you to identify as you read 4 necessities of life. And so you have water, air, food, and a place to live. And so let's talk about those really quick. So the first is water. You can probably survive a pretty good amount of time without any food, but you need water. Every energy reaction, every transfer of carbon dioxide and oxygen in your lungs is water. Water. It has to have water. You can't live very long without water. Remember, we talked about your metabolism and all the chemical reactions in your body. Most of them take place in water. So the first thing about water that's important, we're going to talk mostly on the molecular level here, but there's, we'll talk about the importance of water in ecosystems and that sort of thing later on. Water has what's called a specific heat, which means it can absorb a lot of energy before actually raising its temperature. So it can absorb thermal energy. It's also important the other way around, that it takes a lot for water to lose its energy. Universal solvent. Solvent means that it can dissolve things. Remember, the solute is what's being dissolved, and the solvent is the liquid that's doing the dissolving. And so water can dissolve a lot of things, and that's very important to your body. It has dissolved carbon dioxide in it. It has dissolved oxygen in it. Hormones, vitamins, electrolytes, all of these things are important, and water is able to allow for those chemical reactions to occur because it's a universal solvent. Transport. Your blood is carried by your plasma, which is mostly water. And so the reason why your little toe is still alive is because your heart takes blood and pumps it to your little toe. And at your little toe, it's going to take in that oxygen and it's going to give away its waste product, which is going to be the carbon dioxide. And that water in your blood, that plasma, is going to carry that carbon dioxide up to your lungs, and then you're going to have the exchange. And so the way that your hormones get transmitted, everything that happens in your body is probably caused by a hormone in some way or shape or fashion. So your brain sends a signal to an organ. So for example, if I see a bear on my deck and it's trying to get into the house, I'm probably going to have an adrenaline rush. And that's because my brain is thinking, oh my goodness, I'm in danger. And it sends a hormonal message to my adrenal glands to produce adrenaline. And the way that message gets there, that hormone from my brain, it gets sent through my bloodstream. Air. Now, not all organisms need air in terms of oxygen. So we need to take in oxygen for us to be able to convert the food we eat into energy. And this is called cellular respiration. And we will talk about that more when we get to that part of our year. But it's more or less us intaking food, and in the presence of oxygen, we can make ATP, adenosine triphosphate, ATP, the energy molecule of our body. Some organisms, though, can survive on very low levels of oxygen. We are not one of those organisms. We need O2. Some organisms are called extremophiles and can live in very, 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 very low amounts of oxygen. And from our food, that's one of our necessities, we are going to get our energy. Now, if we back up to the last slide, you need to be aware that plants also undergo cellular respiration. People don't usually take time to think about this. They usually just think, oh, plants make oxygen as their waste product and they make sugars, and think, well, then their energy is taken care of. Not true. Plants need to undergo cellular respiration for their functions of metabolism or chemical reactions also. So plants undergo cellular respiration too. They use food particles, break them down to produce ATP also. Okay, so back to us. We need to eat. And when we eat, our digestive system breaks down our food into the macromolecules that we need, and we take our glucose and break off it one sugar at a time. And when we do that, oh, my GIF isn't playing. Okay, I don't know what's happening. Okay, so I'm sorry you don't get to see the GIF on there. But ATP has 3 phosphates in the molecule, and when we break off one of the phosphates, it turns in from ATP to ADP. And when that bond breaks, that's where we get our energy. The next necessity is a place to live. We like to have a house. We like to be where if it's raining, we don't get wet. We like to be warm. We don't like the wind to be blowing on us. So we like shelter. Different organisms need a place to live. Here we have Nemo. Nemo actually hides in the coral. They have like this little relationship, and we're going to learn what type of relationship they have later on when we talk about relationships among organisms. But you can see how this clownfish can hide within the coral, and that's going to protect him or her from predators. And I bet you're thinking, well, what does the coral get out of it? We're going to learn that. Okay, so this question says, describe how the young eagles are getting the things it needs, the necessities for life. So again, just don't write down one thing. Take some time, put some thought into it. Think outside the box. So for this one, they want you to look at the 4 organisms, and then how does each organism get its food? So hopefully you can do that pretty easily, and we usually learn about predators and prey when we're in elementary school, so hopefully that goes pretty good for you. And for this section of the book, you have what's called a visual summary. And so you have these statements, and it asks you to circle the correct word. And so you have 2 words to choose from that are in blue that completes the statement. And then at the bottom, you have a claims, evidence, and reasoning question. And this, if you remember, is the page that I had you put on the back of your binder. CER. I'm sure you've heard that before in your science classes, where you make a claim, you have evidence to support your claim, and then you explain how that evidence led you to make that claim. So this is going to be more than just a couple of words. So make sure that you're doing what this page says, because we're going to be doing CERs for the rest of the year. And if you remember this page, if we have one on a test or a quiz, it'll help you remember that it's more than just writing down one thing. Okay, that's it for this one.